All right, I think we are live. All right, so today we have Stephen, Aaron, and Druba going through a bunch of stuff, primarily ACPs. There's a lot of, I think we have, what, six or so that we're going to go through today to talk a bit more about it. But before we do that, we'll start off with the, as usual, recap of the latest Avalanche Go release, Cortina 16. So let me share my screen there, and I'll turn it over to Stephen.
Cool. Thanks, Patrick. Yeah, I think the two major kind of components of Cortina 16 that I really wanted to shout out was its namesake, as usual, which is the current concurrent trie prefetching. So this is really a lot more Patrick and Aaron. So I don't know if you guys want to talk about this more than me, but at the crux of it is essentially some database optimizations for the C chain. So I don't know if either of you guys want to talk about that.
I think Aaron, you can kick it off and give an explainer here.
Sure. Yeah. So on the EVM, the way that all of the data is structured is it's into this nested Merkle tree structure. So individual contracts each get their own storage tree. And this means that for a contract that has a much larger storage space, that say has tens of millions of keys as opposed to 5 or 10, it can be a significantly larger tree, which leads to significantly slower access when it needs to read those trees actually from the hash-based database. So what this means is that when we actually need to recalculate the new root after a large number of trie nodes have been modified, such that there's a large number of changes, we have to curse through that tree. And for each individual key that's being updated, it can be up to O of log n total trie nodes that are being read. So if you have a large number of modifications to a single storage tree that happens to be very large, this can be a very heavyweight process. And for the existing implementation of the Go Ethereum trie, that trie is actually not safe for concurrent access. And so what that means is that you can't trivially just parallelize this process, which means that these end up being sequential database reads. So for each individual key, that's O of log n, where n is the size of the tree, and you could have, let's say, 300 or 400 updates. This can end up being a very, very slow and sequential process. And so what we've ended up doing is we wanted to have the simplest possible way in order to parallelize database access for reading these trie nodes without actually breaking that key invariant, which would cause a lot more code changes and be much more dangerous to make, that the trie is not safe for sequential access. And so what we actually did, and I think it was David Bohm that actually came up with this idea, was to, instead of actually trying to parallelize trie access internally to the tree, which is what I originally planned to do, what he actually did was create multiple views on top of the MerkleDB trie, and then just spread out the reads operations that you want to perform across those trie views. And so what that does is it allows each individual trie view to maintain the invariant that it is only safe for sequential access. You don't have to do any sort of jank stuff. And for creating copies of these trees is actually very, very lightweight. And so what you actually do in order to parallelize is just create some number, let's say n of these trie views, and then evenly distribute all of the read operations across these trie copies. And what this does is that allows you to parallelize it very easily and pull all of the nodes into the cache before they actually get used. So there's some optimization and some trade-off between how many trie copies that you want to use versus how much parallelism that you actually get. Because if you have everything is parallelized internally, then what you can actually take advantage of is the fact that they're actually going to share the same reference to all of the trie nodes that it's recursed through so far. But that ends up being a very small optimization, at least as long as the amount of total work that you're doing is sufficiently large. So it ends up being significantly better and significantly simpler to just do these trie views and parallelize that way. I had another implementation that actually parallelized fully internally, which was a really cool implementation. I still am very interested in working on, mostly for the sake of it being an interesting problem to work on. But what we actually saw is that the performance difference between parallelizing internally, so that you can continue to reuse those pointers instead of actually going to the cache, results in a fairly small optimization. So this ended up drastically improving the performance when we're actually processing a block that has a large number of intermediate trie nodes that need to be modified. Patrick, did you want to add anything more?
No, I mean, I think this is a challenge that has been touched on by a number of different folks over time, which is as state gets larger, when you're using a Merkle tray, it gets less efficient to update it. End of the story. Right. And so there's a lot of stuff that's been done, research into making reads faster, basically by replicating or like storing the keys in a way where you don't actually have to traverse the tray to figure out what their values are. Geth has something called a snapshot mechanism that does this. But the other side of it is, well, once you actually make those changes, you still need to have all the intermediate nodes that you avoided reading from before to actually update the root. So you end up, trying to do different things like this to allow you to not have to read everything from disk right when you're generating the root, and better utilizing the resources while maybe you're executing the transactions or something like that. You can take this to the real ends of the optimization spectrum as you want and get extremely carried away with it. And I think as like state gets larger, it's inevitable that people will have to take it to that level of extreme. But this is a good step in that direction where we saw, meaningful improvements in verification time. And so if you're not on 110.16 yet or Cortina 16, we certainly recommend you update just to take advantage of this improvement alone. It will make your node, potentially more stable as well. So just something to take away from there. But yeah, Aaron did a bunch of work on, benchmarking this and like putting together a bunch of different ideas of how you could do it. So I think, I don't have much more to add on that. I think there's Aaron, maybe if you want to drop the issue you posted on Go Ethereum that outlines some of those ideas that we can share in the chat, that'd be great. Stephen, if you want to cover the next topic that you said you wanted to touch on.
Yeah, so the next kind of large-ish change in this release was some pretty significant refactoring of the bootstrapping engine. So one of the things is it completely removes the Avalanche bootstrapping engine for at least detecting the stop vertex that was introduced in Cortina. So that's able to be fully removed. And in doing so, we were also able to fully kind of inline the bootstrapping logic into the Snowman engine. So there's a pretty significant rewrite of the bootstrapping code, which is basically a nod towards the ongoing work to make the consensus engine more concurrent. So we're basically trying to simplify, clean everything up into kind of more separable data structures that are then easier to parallelize and manage than kind of the existing flow, which was a little bit complicated because it had to be shared across like different engines, and it was complicated to understand the control flow of switching between engines. So that was another large part of this release. So seeing as no one has complained about any bootstrapping issues since this release, I think we're happy with how that's going. And then I think the rest of this release is a lot of kind of like smaller things with a couple fixes that are listed here and a couple cleanups. So another shout out to the Merkle DBs. We finally removed the Sentinel node from the Merkle DB proofs, which I'm a huge fan of. So I'm super excited that finally got in. Essentially, there was a kind of odd case where if you had a really small tree, you could end up having like this like additional root node that I was not a fan of, and so we fully removed that to have a cleaner theoretical tree, even if the actual implementation still has that Sentinel node in it. So yeah, a couple small things like that as we kind of work our way towards like fully productionizing like Merkle DB and some of the networking SDKs. But yeah, I think those are the main things I wanted to shout out.
Yeah, I think we scheduled MerkleDB for an audit as well coming up before we get to production use. So some people were interested as well in that. So as soon as that audit's there, you'll be able to use it. We already use it in the HyperSDK, but we really wanted to make sure MerkleDB was independently reviewed before we introduced it into the X or P chain, which is the next step for that. The other thing I want to call out, which you hadn't mentioned yet, was this 2253, this track all subnet validator sets in the validator manager, because I think this was also a pretty meaningful change. You wrote this code, so if you want to introduce it, feel free. Otherwise, I'm happy to go into it.
Yeah, so this is actually based a lot off of Jay's work, which I believe was done in a prior release, which essentially refactored how we could track validator sets. And so this actually activates it. So now we fully track all subnet validators inside the validator manager, which enables us to perform things like observe the validator set on a given subnet inside of, say, the networking code, or also perform like stake-weighted sampling of any given subnet validator set. So this unblocks so this enables in this PR pretty much only the p-chain sample validators. You can now call it on any subnet ID and that will work, whereas previously it had to be a tracked subnet. But what this is really kind of making progress to is exposing this subnet information to the networking code. So I know that there's a number of ACPs ongoing right now related to different rules for subnet validation. And so if those ACPs go through, which I think so far there's been on a whole positive engagement from the community on those, then this will be very critical to kind of unblocking the networking component of the subnet validation rule changes. So I don't know if you want to use that as a segue into the talk of our ACPs, because I know that there are a lot to talk about, but yeah.
Yeah, I think I'll take the nod, move right into that. So yeah, a lot of what we wanted to chat about today was presenting some of the ACPs that the three of us have written, or four of us have written. And so, as more people publish different ACPs, we'll be certainly interested in chatting with them and bringing them on to discuss some of that. And I think the first thing before we dive into that is to review a bit about what at least the workflow is for writing these ACPs and like how they actually could get adopted on the network. Because I think that's been one of the most common questions, mostly because it's a new thing, and then secondly, also because none have gotten to that stage yet. So no, there is no like prototypical example to follow. So step zero, which we're zero indexing people here, we're engineers, so we started step zero, is to obviously think of something novel to implement. And so this may sound like a dumb step, but it's important to, obviously soft review, kind of conceptualize what could happen here, and understand like that what ACPs are for are really meaningful changes to the network, and hopefully things that push Avalanche, the community, forward. Once you think you have something like that, it's important to post if you feel. I think this is probably something I could put as an optional thing, honestly, but you can post your idea to GitHub discussions. And so this is to say, writing an ACP takes time. You probably don't want to spend the time writing an ACP if everyone or like a bunch of people in the community are like, no, don't do this, or like there's meaningful feedback to give. And so there's a section of the discussions called ideas, where you can post different ideas for things that could eventually become ACPs. And so I think Rishi here, Rishi posted something about subnet rebranding. And so before writing ACP, he put a bunch of different things of like what an ACP could look like, and people have engaged, with some of those comments. The same thing was done actually for some of the subnet only validator work as well. This ended up probably being the most popular discussion we've seen. I think there's 24 participants here. And so this ended up being a really long running conversation. But the idea here is share some ideas. Maybe you have conviction on what you're doing. Maybe you're a little unsure. This is the place to post it. Once that happens, you propose an ACP. So this is where most of the initial work goes into, is actually just generating a well-formatted ACP. And so, for example, like some of these earlier ones, like p-chain transfers here, the initial ACP spec, and the important part here is it's marked as proposed. So there are a number of different statuses that an ACP can have, but the first one, as soon as it's live, is proposed. From there, that's where like you have the option to collect feedback. So, I propose this ACP actually, so now we should all, maybe take it seriously, have conversations about it, suggest feedback. I think one of the good thing, or like an example of really good changes that happen in this stage, is like maturing some of the recommendations. So one of them was for ACP 20, which was something that Druba has been working on, where the recommended library was changed after some conversation with Filippo, who is the Golang security maintainer. Golang cryptography maintainer, I apologize. So that would be an example of, hey, you know, like we want to use this stuff. Here's some examples of what we would plan to implement. What do people think about it? Great. All right. Like we can make a change or it's good to go. Now, once engagement kind of has wrapped up around an ACP. So like, you know, you as the ACP author have listened to people's feedback, or people haven't expressed any strong feedback, and you think that the ACP is well-defined and could be implemented, that's where things start to get interesting. You move the ACP into a implementable state. So this is step 4. And so when something is implementable, the spec should be fully complete and it should more or less be considered locked. So like you shouldn't, like there shouldn't be major changes to the spec at that point. You know, at that, if you're making major changes, then you should probably mark that ACP as stale and create a new ACP. The idea is to move forward here. So like if you're in implementable and then you realize you have to make a bunch of changes, you're not supposed to really, at least as far as I understand, go backwards. So implementable is the next step. And when something is implementable, it is considered something that could be implemented by any of the Avalanche network clients, something like AvalancheGo. So implementable means that if you support the ACP, or like generally support it, you would run code that incorporates that ACP. So this is where I think there's a lot more community work that could be done to gauge sentiment of how well supported an ACP is before it's actually suggested to be part of an upgrade. So right now there's like this straw man proposal where you can sign messages and post them to the ACP to indicate your support. You know, naturally it's a little cumbersome, right? Like also people want to typically maintain anonymity, and you have to attach it to a GitHub account. And so I think something that we'd really like to do in the future as part of the handshake for a validator, that you could signal your support for different ACPs. And then it would be easy for any validator to gauge how well supported ACPs are across the network before they're proposed for actual activation. But once something is implementable, the idea is that it could become active on the network at some point. And for things that the Avalanche Foundation feels strongly about, it can recommend the ratification of certain ACPs. Now, that recommendation means nothing other than that the Avalanche Foundation thinks that it's a reasonable idea. So it's not, you know, not a binding thing, not anything like that, but just to help signal their support for certain things. So the process really then becomes take your ACP, or in summary, propose an ACP, collect feedback on it. Once feedback has been provided, whether or not it's been addressed, ACP can be moved to implementable. Once it's implementable, it should have a fully defined specification and a reference implementation. And then once it's in that implementable stage, it would be considered as a potential option for a upgrade, and could also be recommended by the foundation. And then if people oppose said changes, they would simply you know, indicate that on the ACP. But in the future, it'll be much more dynamic, and people will be able to indicate that via the handshake on their validators. And then something, you know, people, the big question, right, is, well, you have these stages, how does something actually get ratified? And that is really if enough stake on the network runs the code that actually activates that change. This is similar to how something like Bitcoin or Ethereum works as well, which is the network continues with new code if the majority or supermajority of stake runs that code. Now, hopefully with some of these things, you're not actually right at that threshold, because that can cause some serious instability on the network, right? And so usually these ideas, you want to be very uniform. I think that the like Bitcoin soft fork activation, for example, is like 90% of mining power over some window. If that is true, then it becomes activated. I'm not sure what some of the other folks do in terms of like gauging sentiment. But generally speaking, you don't want these things to be contentious, right? And so the better tooling we have to indicate this sort of support, the more effective this could be. And so I'm looking forward really to seeing people take a stab at that, as well as trying to add support to that handshake for AvalancheGo to better gauge that. I think it'd be really similar to right now you can basically ask peers what their view of your uptime is, and I think we could use something similar to that to kind of gauge people's kind of view on different ACPs, and then you as a node runner, you auto default to like neutral, and then you could update some sort of configuration that would say like whether or not you're in favor or against certain things. Then the super cool option in the future is that if we see sustained support for something for a while, then it just becomes activated at some point, and that is like the vote process. But that's a little bit more hairy. I'm sure Stephen has. I know Stephen has ideas about this, but that's generally the process, as far as I understand it. And so from there, I think we can talk about a number of the ACPs that different people have proposed that we can kind of give a summary of. So I was going to just do them in order based on the stuff that I think is closest to probably implementable or already implementable. So I think we'll start off with 23, unless anyone wants to chime in on process or has questions, actually. Cool. I think we can go right to 23 then. Druba,
Yeah,
take us away.
thanks. So for ACP 23, we talked about this in the last community call already, so I'm not going to go and present it again. One thing I did want to highlight about this ACP is we did have a comment in the discussions before it was marked implementable. Patrick, if you just want to hit the discussions link at the top. So somebody, so I'm gonna butcher that username, so I'm not even gonna try. But so somebody mentioned that the X chain already supports cheap and quick transactions. Why would I ever want to leave the P chain to use the X chain? Isn't this feature creep? And that's a fair point. I think that if you are only interested in staking, though, you shouldn't have to leave the P chain necessarily. You increase your trust boundary. And since staking is such a critical operation and potentially involves a ton of funds, you want to maintain a low trust boundary whenever you're doing operations related to that. The demand for native transfers on P-Chain is also already there. We've seen in production that validators are using other transactions not meant for native transfers to replicate that functionality. We touched on this a little bit in the last dev community call as well. Um, the feature creep comment is definitely noted, though. We don't want to, start enabling smart contracts on the P chain or something like that. We're trying to keep the P chain as minimal as possible because every single validator, subnets included, have to run the P chain, even in a subnet only validator world, as outlined in ACP 13. So we're very cognizant of that feature creep, but we think that this is a change that is highly demanded by the community and will only serve to ease staking operations on the network. So that's all for ACP 23. I think there's a couple of others.
Yeah, I think the point about understanding like what sort of additional load this could impose on the P chain is where a lot of the conversation currently is. You know, as Drupa mentioned, like everyone is going to be syncing this thing, and so we don't want to turn it into like a really heavy chain and require then now the same same problem we're trying to avoid with having the PX and C chain. And so some thought has been going into that. And then I think just to loop around on the point about like people are already doing it on chain, um, as protocol like implementers and designers, anyone, right? Like you have certain ideas of how people will use the protocol, and then you have what ends up happening of what people actually do on the protocol, right? I think the most prevalent example of this is probably like some of the liquid staking stuff on ETH. I don't think people imagined initially that like a huge amount of the ETH to stake would be held by liquid staking providers. Similarly, no one assumed or had the idea that you could potentially reuse that security in restaking. And so what ends up happening then is as the environment moves around you, as the protocol group, like what do you end up doing with that? Do you try to make it easier, harder, more efficient, whatever, right? And so this is a similar question there, which is if people are already doing this because they want to avoid indexing multiple chains, or in some cases, some custodians like aren't really interested in moving chains within the same ecosystem. They just want to stay on the same thing. Do you, with a straight face, recommend using like some some other transaction type to accomplish the same thing, or do you try to add native support, which is much more efficient than the alternative? Um, and so that is probably what is much more efficient. And so the idea then would be, this is I think wrapping up and going down that direction. So yeah, so I think, Juba, you marked this as implementable a few days ago, right?
Yep. There hasn't been too much more discussion on Twitter or GitHub discussions aside from that feature creep comment. So I felt it was in an implementable stage. The reference implementation has already been included into AvalancheGo as well. So please, if you dissent against it, the GitHub discussions are always open. But we feel pretty confident that this is in a good spot.
Cool. All right, next one. Activate Shanghai EIPs. Aaron, maybe you want to cover this one? I think you
Sure.
probably should have had Aryusha here. That's my bad.
Sure. Yeah. So there's a number of EIPs that were already included in the Shanghai upgrade on Ethereum. And so we've already added these into the reference implementation for Core ETH to just activate them as of the D upgrade. And this is basically just saying, as Ethereum has activated these EIPs and the standard of what is expected of an Ethereum network has changed slightly to have each of them activated, we wanted to also activate them on the C chain as well as activate them on Subnet EVM in order to just maintain parity with Ethereum upstream. So this is a very simple ACP, basically just to propose that we continue that trend of activating these EIPs in a network upgrade that trails after they launch on Ethereum mainnet. So to go into each of them individually, you can check out EIP 3651, 3855, 3860, and my favorite is 6049, which officially deprecates the self-destruct opcode. This has been a very interesting one that people have been passionate about either removing or making sure that it was still there for a very long time. And this one was really funny because when I looked at it, I was like, wait, I haven't seen that in the code that they actually removed self-destruct. And so this one is actually just marking it as deprecated and not actually removing the code. And it'll still be removed in a future upgrade. So there's also a proposal to actually officially deprecate it. So if you have any contracts on the C chain or Subnet EVM that are actively using self-destruct in some way, this would be a good one to comment on and just voice your support or against, because we are marking it as officially deprecated in accordance with upstream. Yeah, that's pretty much it for ACP 24.
Yeah, the current ideas for like what this is important. I think people have always wondered, what our support strategy is for the EVM, and thus far, it's really been trying to maintain as much compatibility as possible. And so, for anything where we're differing deeply from like upstream EVM support, I think the perfect example of this would be introducing Teleporter, for example. Doesn't make sense upstream, right? It's a breakaway from like the standard EVM model, but super useful for Avalanche. But for other things where it has to do with like the semantics of actual like Solidity bytecode execution, the interest from the community seemingly has been to try and make it feel as similar as possible to ETH, which is a similar approach that all the L2s have taken as well, I think. And so self-destruct in particular is one that has been a long-running conversation with a number of people. And what I think that the upstream, ETH community is planning to do there is, to only allow self-destruct within a single transaction and not across transaction boundaries or block boundary. So if you are working on a contract that does something like that for some reason, I recommend checking out some of the upstream EIPs that discuss this.
Yeah, I think in here as well, another big one is the actual push zero instruction, just because Solidity now, I think the latest versions do include this. And so this will re-enable the usage of the newer Solidity versions on EVMs launched in Avalanche. So that'll be a nice UX boost. I know we talked a lot about self-destruct, but that's actually doesn't necessarily impact UX yet. but push 0 should be a tractable improvement. So that should be nice.
Yep. Yeah, I think that's pretty much it. The push 0 one is obviously the big one because you can now use Solidity 8.2 or greater, which is really important for like tooling and stuff like that. Cool. So I think we'll go to the next one, which is application. Oh, actually, before we do that, I don't know if you can speak for Dariush or not, but like where the activation. Oh, it looks like or where the implementable version of that is, because I think that one's still in proposed status, right?
Yeah, so that's already been, we had actually already migrated the code for this prior to the introduction of the ACP process. So we can probably mark this one as implementable at this point. It's obviously, the EIPs have already existed in Ethereum upstream for a long time. So the standard is not likely to change. I'd say it's very much implementable at this point, and there is already a reference implementation available for it. So I think we can just make a PR to mark this as implementable and move it to that stage. It's just about actually making that PR to do so. Yeah.
Sounds good. All right, Lex, we'll go to the virtual machine application errors. Steven, if you want to take that, or Druba.
Oh, I can talk about this. So I think Josh may have already talked about this during a prior dev call as well, but essentially right now we have ways that AvalancheGo communicates with other AvalancheGo instances over the P2P network, and one of those ways is specific for VM communication. So a blockchain can implement their own custom kind of communication protocol, and we use this for things like statesync or like things like mempool gossip, things like that. But currently there is not a way to easily report errors during that communication protocol. So as an example, maybe we introduce a new message to the mempool communication, like gossip protocol. And if a node hasn't updated to support that new message yet, it currently just drops it. And as a whole, kind of it's the best practice to actually reply to that with a explicit "I don't support this" message type to avoid hitting any kind of timeout conditions. So we saw, I think, when we first rolled out some of the pull gossip for the C-chain mempool, that the lack of this really impacted some of the kind of dissemination and also like uptime tracking of the node. And so this is an improvement to kind of alleviate that and explicitly provide that kind of best practice unsupported error. So because it is a general communication protocol, it's not specific at all to any like C-chain gossip, but it's just kind of explicitly adding that capability to report an error to the client, the caller. So yeah. So that's the focus of this. I think that there have been a few changes in the kind of pull request that's kind of tracking this on the corresponding side into AvalancheGo. So I'm not sure if this is marked as implementable yet, but it's definitely getting pretty close. Yeah.
I don't think it is. I think it's just proposed right now.
Yeah. It's definitely getting pretty close.
There hasn't been much feedback on some of these. Like, I think they're pretty low-level technical considerations that they're just better or improvements. Like, I'm not sure there's really much to debate, I guess, unless you're like a timeout maxi. So, which I don't know anyone that's in that position, but maybe there are. I don't know. But the whole point with these ACPs, right, is to fully enumerate breaking changes to the protocol standards. And so, although this may seem minimal, it is definitely a change and the requirement of a new message type. So that's something that should be included here. You may also have wondered as a listener, like, why are we not spending any time on ACP 13 or ACP 20 at this point? The reason for that is they're both still undergoing feedback and review, so not really close to the implementable phase, in my opinion. Cool. Next, we'll go to Warp, the big one.
Yeah. So I think everybody's heard about Avalanche Warp Messaging, and people probably heard about the fact that we're integrating into the EVM for a long time. So this is another one where our work on this predates the actual ACP process. So there's that's the one active PR in this repo, is to mark this as implementable. I think we talked about this on the last call too, so I won't go into too much detail on like the motivations or the specification here. But we've had Avalanche Warp Messaging as a high-level protocol design on Avalanche since last November. And so this work proposes in how we would integrate it into the EVM on both the Avalanche C chain as well as into the Subnet EVM virtual machine, so that subnets using Subnet EVM can communicate with the C chain and vice versa, as well as proposing a standard that the C chain will use so that any other virtual machine that exists can choose to follow and comply with that standard, so it can send messages both directly to the C chain or to any other subnet that's using the same standard. So this includes a couple of different message types that include both signing a block hash as well as an address call, which specifies the source chain ID or the chain that's sending the message, as well as the address, which is an arbitrary byte array, not a specific 20 byte address that is used on Ethereum, to allow for more flexibility across different potential VMs, both in the future as well as the HyperSDK that already exists now. And leaves it up to a message protocol defined on top of that to define what actually goes into an arbitrary byte payload. So you might think if you have an address call type message, you obviously wanted to specify exactly who you're calling on the receiving end. But what we actually opted to do was, because that is not necessarily needed to authenticate who sent it, we actually leave that to a message format to define on top of it. So this has already been implemented by Teleporter, which is slated to launch alongside or very soon after Avalanche Warp Messaging launches on Fuji and Mainnet. So that will actually provide that protocol built on top that specifies what is the destination chain ID, what is the destination address. And the core motivation for this design decision was to limit the scope of what has to go into the C chain and subnet EVM to the smallest possible trusted computing base. So this has led to it being a fairly easy to reason about design. And we went through multiple audit/security reviews with a couple of different partners that have had great things to say about the security and ease of review and how well documented this is. So it was really great to see that feedback. And really great to see that because of these design decisions, it's very, very easy to reason about, and it allows a lot of flexibility for protocols to build on top of it. Since we've moved a couple of things around to continue moving more and more out of this protocol, it has led to some code shuffling within Teleporter. So thanks to that team for their patience as we made some of those design decisions. But with that, I'd love to see any discussion on this. So right now, there hasn't been much discussion. I think that's just because the community is by and large in support of it. This has been something that we've been talking about for a long time. And like I mentioned, this is something that we've been working on predating the actual ACP process. So there is that PR to market as implementable, and it has already been fully implemented on Subnet EVM. And the last PR is up and has one approval and just needs one more to finish migrating that implementation into CoreETH as well. And then we just slate it to launch in the D upgrade, assuming that the community gets behind it. So yeah, super excited for this one and to see Warp get out the door in production used on the EVM.
Yeah, I think if people are looking for things to dive deeper into and express feedback on, it's probably the use of the EIP 2930 access list to include some of the message data. There's a lot of reasons for that. I think they're enumerated here, but that's certainly one that is an interesting aspect of the design. And then also probably reviewing some of the gas usage costs, which when I looked at it, I thought were actually pretty reasonable as far as things go. So I was pretty excited by that. But yeah, I think what will happen here, just for people's kind of sake, is we've been talking about Warp forever. We've been thinking about Warp forever. We've been working on Warp forever. It's funny. I remember Steven doesn't tweet much, but he tweeted one thing one time, and that was almost a year ago now, which was the timestamp in which the first Warp message was sent on the mainnet. So it's crazy to think that finally, almost a year later, we've found a way to what we feel like is really cleanly integrate Warp into like the EVM, which is the most commonly used virtual machine on Avalanche right now. And then what that will do, obviously, is let you take Avalanche or any ERC20 and bring that into your subnet. And so I think outside of the introduction of Warp, which was one of the biggest things ever added to Avalanche, this is definitely probably number two, and I think really will change the topology or really the way people use Avalanche.
One question that I see coming from 0x Acid, is it safe to assume that AWM will be available for EVM x EVM cross-chain messaging, or to put it differently, a subnet using an alternative count model won't be compatible with Warp? So to answer this, yes, it will be compatible with EVM to EVM cross-chain messaging. Anything that is using the latest version of Subnet EVM that has Warp activated, as well as the C chain, will be able to use the same Avalanche Warp messaging precompile. For any other account model or any other VM that's using a different account model, they will still be able to integrate with this approach. They will just have to come up with their own way to integrate Warp messaging that complies with that same message format. So for example, HyperSDK can actually use the exact same message format in order to send an address call to another EVM chain on Avalanche. And it doesn't actually need to know, and the contract on the C chain or on any other EVM chain doesn't even need to know that the HyperSDK is talking or is a non-EVM chain in the first place. All that it needs to know is how to deserialize that message and handle it appropriately. So as long as the HyperSDK integrates with Teleporter on top of it to comply with the exact same format, anybody will be able to use it in the exact same way and it will behave as if we're talking to another EVM chain.
Yeah, from the subnet's perspective, what you need to do is like the C chain to subnet part, the virtual machine that actually reads the C chain or interacts with the C chain controls that handling. So however they want to represent that on the chain coming in. And then on the way going out, so this is like from the subnet back to the C chain, you need to populate a payload that the C chain precompile that supports Warp or Teleporter can understand. So in the case of the Hyper SDK, what that would mean is probably some sort of conversion between like some sending EVM address to like some arbitrary bytes where like the asset would go to on the Hyper SDK. But the payload format is generic. So it's not like you have to like have the same account model or even account format on the destination. The important part though is the way you should think about it is if you want to use assets from the C chain, you need to be able to speak C chain to get those assets. It's not really feasible for the C chain to learn how to speak every other possible language to give you those assets, right? And I think that's the way I kind of tail bound some of the complexity. So if you want to learn more about like what the underlying serialization format that people are using, I'm sharing the screen now, but I'll drop it in here for Kyle to share in the comments.
You could also
there's a few. Go ahead.
You also might want to share the payload subdirectory that you're in, because that's going to be the read that'll contain a README. Yeah, there it is. That has the actual message formats encoded in the Avalanche Warp message too.
Yeah, so initially, a lot of the stuff will probably use this addressed call, which is easier to reason about, but less scalable. And then in the future, I think people will switch probably to this hash-based message format, where you can more or less include like the root of a tray that represents like some large set of messages, which is, you basically can amortize the cost of the BLS multi-signature verification, which at the end of the day ends up being the bottleneck with Warp. So you can imagine like, I've emitted, 1,000 events. I now put together some tray, and then anyone on the destination that wants to interact with what they brought over just has to post a proof with that tray. And, 1,000 events is great, right? But from a tray perspective, you only have to prove a depth of like 3 or 4 keys or something like that. If it's a binary tree, so not at all too onerous to actually do that. So yeah, I think that's probably a good overview of where that's at. Like I said, I think it's really cool. I think the work that has gone into like testing and auditing this has been immense. So it's been great to work with different partners on that. And I think if you're interested to see how it all comes together, Aaron and the rest of the EVM group have been working on a series of end-to-end tests that actually like go through the entire flow in CI for every commit to make sure that it remains stable. All right, next one we have here. We're rapidly running out of time as usual. So Druba.
Yeah, so this one is related to making subnet management a lot more tenable for more security conscious folks, and also just a general best practices thing. So currently the Avalanche P chain only supports registering a subnet, and when you register a subnet, the owner you specify in the registration transaction to create subnet TX is immutable. So obviously, like for bus factor concerns, security concerns, as your subnet grows up, there could be many reasons why you would want to change the owner. Maybe you're moving from one address to a multi-sig, but this isn't currently supported. So this ACP is targeted around adding a new transaction type, which is pretty straightforward, just to rotate the owner. So you use your original owner to sign some transaction, in this case, the transfer of subnet ownership TX, and then you provide the new owner, and then it just transfers the ownership of the subnet. This one is a pretty straightforward PR as well. Like the reference implementation is, I think, roughly like 1,000 lines, but most of that's around testing. And we feel pretty confident about this change. We've talked to multiple subnet operators already about it, and they've all expressed heavy interest in it. I think this is probably one of the least contentious ACPs we'll ever have. So we're super excited to continue listening to feedback from subnet operators and how we can help improve their user experience as they set about creating their ecosystems.
Yeah, I think the feedback we've also heard too is like because previously this was so set in stone that a lot of time was spent just on setting up some sort of like key policy prior to subnet launch, because there was no expectation you'd be able to rotate it. But anyone that is anywhat versed in security understands that like a big part of key security is just frequent rotations of keys as time goes on. And so this, aligns subnet management with a much clearer and well understood security posture, which is really important for some of the larger enterprises that are maybe by mandate have to rotate keys like this on a regular basis. So, as Druba mentioned, shouldn't be too controversial, I guess. Yeah, and then the last one we have here is remove pending stakers. So I think this is another Druba special.
Thanks, Patrick. So this one's a lot larger than the other ones I've written, simply because it changes the staking dynamics on the P chain. So taking a little bit of a step back, whenever you issue a staking transaction, this could be adding a validator, this could be adding a delegator, you have to specify a start time and an end time. Now, the start time has to be like a little bit in the future, but not too far in the future. However, this increases the computational load on the P chain quite a bit because we actually then have to maintain a pending set and a current set of stakers. After a certain period of time, once the start time is hit for a pending staker, we then have to promote it to a current staker, which is additional computational load. Another slightly nuanced one that is also very computationally heavy is checking whether or not a delegator will push a validator over the max stake amount that can be allocated to a validator. So this would include, iterating through basically all of the delegators to make sure that whatever start time the new delegator has included doesn't push it over the edge for that staking period. All in all, this greatly increases the computational load on the P chain. And as mentioned before, since the P chain is going to be the common chain for all validators, including subnet-only validators, as systems designers, we want to make it as minimally as minimal as possible in terms of computational resources to sync. We've also haven't received too much user feedback that the start time is very beneficial to them. It's not super helpful to the users, pretty bad for the chain. Seems like pretty straightforward to get rid of it altogether. So the concrete change here is removing the start time as a user set parameter. So no transaction types are actually going to be altered to do this. The only thing that's actually going to change is start time specified in the transaction is not going to be honored. Only the end time will be honored. So if your end time is a year in the future, that's it. That is still canonically when you will get your stake back and any rewards associated with your staker. So most of this stuff is done on the back end, as mentioned. So transaction types aren't going to change. It's really just streamlining a lot of the P-chain processes, making it more efficient on a going forward basis. The specifications there for you guys to read. We are currently working on the reference implementation, but I think the ACP itself is in an implementable stage. So watch out for those PRs. I think that's about everything, Steven. I don't know if I missed anything.
No, I think that there was one question that someone asked, which was basically around why the start time ever existed, and essentially the start time was added because we were working on basically an alternative kind of staking design in the early days, and then after some modifications were made to the staking design, the start time was really no longer needed, but still existed. So essentially, after BAMF, the start time is really not important at all. And yeah, so this is really almost like a post BAMF cleanup in some ways, to kind of like really streamline the verification process. So yeah, I'm really excited for this PR. I think this will substantially simplify the P chain. So yeah.
Yeah, I think something to just reiterate is that a lot of the thought around the P-chain optimizations is solely based on every validator has to run this. If you're a subnet, this is something you have to run. So making sure that this is as small of a footprint as possible on your computational resources will make running your subnet more efficient. If there's a lot of throughput on the P-chain, as could be caused by the native transfers, we want to make sure that it's mitigated as much as possible to reduce the amount of impact it has on the whole network.
Yeah. For most people though, like that whole like start time setting thing where you set it far enough ahead that like you can go sign it in time, is a thing of the past. And I think that's really what people should be excited about.
Yeah, I think really the only edge case here is if you have like a start time that starts like say 5 minutes in the future, and then you have an end time that's like 1 year and 5 minutes in the future. Those transactions are no longer valid to be issued immediately because the start time is essentially overridden by your current time when you issue the transaction. So there's a small edge case that wallets will need to support if you're essentially issuing a max duration validator. But aside from that, there's essentially no upstream impact. Yeah.
Yeah, that's it. So yeah, if you want to keep track of like the ACPs that have been merged and are proposed or implementable, there's this ACP tracker you can go check out that shows everything in their current stage. So, with all the like, there's not even that many yet, and I was struggling to keep track of this. So this has, I think, been a great addition to this repository, is to kind of see where everything is with the descriptions of like what those phases are. So as more stuff is, implementable and recommended or stale, like this will be updated correspondingly. And so also to remind folks, like there's a number of open discussions in the ACP repo that are not yet ACPs. They won't show up on here. Like ACP has to be officially like merged in and proposed for it to show up on the tracker. Yeah.
This is sick. Is this a GitHub project board?
Yep. Yeah, it's run by the foundation.
Oh, cool.
Yeah, and then if you click into it, it has like a description of what like the summary thing is, with a link to the ACP as well as a link to the discussion.
Oh, okay. I thought it was doing this based off of keyword in the actual text, but these are just kept.
Oh, that'd be super.
That's
cool
what I thought was
that
happening. I thought that was
possible. Yeah. Yeah, if you want to make a bot and wrap it up in here, that'd be pretty sick. Yeah,
that's what I thought was already happening. Oh, that's cool.
Someday, yeah, we'll ask ChatGPT to do it or something. Yeah, so I think that pretty much wraps it up. I was going to I think we have 2 minutes left. And there was one or two more topics I thought we could cover, but I think it makes sense just to wrap it up here. And so yeah, I think, if you've have opinions on any of the stuff that's been discussed today, like you should definitely reach out on the discussion boards and share your views on what is good or bad about them. So every ACP that's in like the proposed stage has an official discussion where anyone with a GitHub account can chime in and share any feedback. There's a ton of feedback still that I need to address for people that brought up on ACP 13. But otherwise, like there's great places to chime in here. And if there's any particular ACP that you feel for some reason should very strongly not be merged, it is important to indicate that on the ACP process because that is what the Avalanche Foundation uses to determine recommendations of whether or not things should be adopted. So if they're looking at some sort of ACPs and, for example, like the Shanghai EIP one, and there's no supporters or no objectors, it's viewed as more or less neutral and that if it could be merged, right? But if there's a bunch of people here with large stake that object to it, that should obviously give everyone concern to consider it for an upgrade. So it's important for this process until we have like the better handshake or like kind of signaling of your beliefs that this somehow you find a way to express your belief here. Cool.
Awesome.
All right, there's a quick unrelated question. How much data can we store in a single key of the MerkleDB?
So okay, this is a good question. So the MerkleDB generally does not restrict the sizes of the values. So it's up to the virtual machine to add any such restrictions. So I know not to talk about Patrick's work with because he's right here, right? But the Hyper SDK essentially you allocate a size for your key, and so then you end up paying based on like the maximum size of that key that you're interacting with. So that's one way to do it. A way that a more like EVM focused implementer would do it to be fixed 32 byte chunks. But yeah, so it depends on the VM at the end of the day. The MerkleDB is agnostic. Yeah.
Cool. Yeah, I think we'll wrap it up there. I think we're right around the hour mark, and so yeah, thanks for listening. And yeah, this is obviously these ACPs we presented them here because we wrote those ones, but the approval and activation of them are not something that Avalabs controls or anything. So if you have any feedback, you should definitely post it. And if a lively conversation starts up on any one of them, I think it'd be great to have a separate conversation about that. Cool. All right. Thanks, everybody. Talk to you later.
See you.
Thanks, everybody.